Yeah, in this class we'll be focusing on a few things, Numpy and pandas. So maybe we'll try to complete this Numpy and pandas in 2 sessions. So right now we'll go through Numpy. Okay. So Numpy and pandas. So these are useful for data analysis. Okay. So data analysis related stuff. So like analyzing the data. Like before going into data engineering skill set, so I'd recommend go through Numpy and pandas because these are basics of any data engineering, data engineering things. So I'll just share my screen. Okay, now let's get into some kind of simple like theoretical concepts like what is NumPy and all. So let's get into that. Okay, if you could see, NumPy is a Python library. So pandas is also Python library. C1 is also Python library. So likewise, so NumPy is used for working with arrays. So NumPy is a short for numerical Python. So basically, NumPy you will be like it's an array. Okay, basically if you wanted to work with array in the sense basically you'll be having arrays, right? Like in Python, in Java you'll be having array. It's nothing but list of elements. Okay, list of elements, but array is something. It's similar. Okay, similar kind of thing. Uh, and next. Yeah, that's it. So related to NumPy. So NumPy is the Python library used for working with arrays. It also has functions for working in domain of linear algebra, this all on matrices and creating this. So it's an open source project. So whatever libraries comes from Python, most of them are open source. And why we use some NumPy in Python, we have lists, right? So that's the purpose of arrays. So basically, we don't have, arrays in like in Java we have arrays. In Python we don't have arrays. So but we have lists. Okay, that's the purpose of arrays. It seems like arrays, but they are slow to process. Okay, the lists are slow to process. But if you talk about NumPy, so it will be faster than lists. Okay, so that is one of the advantage of NumPy. So we have in Python we have list, but if we also have arrays in NumPy, like using NumPy library, you can create an arrays, okay, which are faster. I mean, which are faster than list. So it's fast. You can see 50 times faster than traditional Python lists. So the array object in NumPy is called ND array, and it provides a lot of supporting functions that makes working with ND array very easy. Okay, so these things, let's get into this again now. So we will go through this. So before getting into NumPy, so I mean, you have to install these things, right? Libraries. So whenever you wanted to install some Python packages or Python libraries, you use pip, okay? Pip install NumPy, pip install pandas, pip install cbon, matplotlib. So whatever you wanted to install, so you can install using this pip command. Okay, before installing this pip command, I mean using this command, you also have to install pip on your computer. Okay, pip on your command line, or maybe this way you will be installing something, some curl command or some command will be there. So you can get it from internet how you will be installing pip. So after that, whenever in Python, you can just in the Jupyter notebook or in a Python environment, you can use this. Okay. So we have installed pip NumPy, and it says requirement already satisfied because we already installed it. So yeah, it doesn't make any sense installing again and again. So import NumPy as NP. So whatever you wanted to use any library. Let's suppose if you want to use pandas, as I said, you have to use import. Okay. So now if you could say import NumPy as NP. So NP is nothing but it's a short form of NumPy. Instead of writing NumPy, I can make this way. Okay, and import NumPy. Okay, so NumPy dot array of L1. So likewise also it's possible. Okay, but I just wanted to make it NP. I just created this way. So that short form basically. So here is a list, and here I just written a variable called ARR, which is equals to np.array L1, np.array L1. L1 means this, and print array. So this, so you can see 1, 2, 3, 4, 5. So you can see it seems like same as list, but you can see there is no comma between this. Okay, that is one difference you can find. So this is same as list, and this is both represent. This is actually list, right? So L1 equals to 1 2 3 4 5, which is a list, and with the help of the list, we have created an array. You can see arr dot np dot array of L1, right? So print arr. So this is 1 2 3 4 5 without commas. Just try to understand that there is no commas, and it seems like a list. That is what array is. So this, if you could see, type of L1, you can see list, and type of error, which is numpy.end-array. Okay, this is how also you can check the things. And now again we will this is the same syntax. I'm just removing this, and you can see two-dimensional array. So basically, if you could see, if you remember your childhood days, you have matrices, right? So matrices like 1 into 1 matrices, or 2 into 2 matrices, 3 into 3 matrices, likewise. So here, if you could see NDRA, so I mean basically um, numpy as NP. So you don't need to import every time. Okay, I can remove this because it's already imported here, right? So for this particular notebook, so I have imported this. Okay, it's not only for cell, it's for complete notebook. I don't need to again import it. Okay. So you might be thinking we need to import always, not like that. So once I imported for this notebook, that's fine. So you have to import at the start, okay? Because you didn't import this, you just get this command at the end. You're trying to use it at the start, so this command won't be executed, right? At last, it will execute it. So, so this should be at start. Whatever, not only this number, whatever you are planning to import, that those all should be at the top of the code. So if you could see my code, um, AWS project. So AWS project, and if I take any of the script, you can see how many I have imported. From date time, import date time. So from AWS glue, import glue context. So likewise, I have imported a lot of things at the start itself, so that it shouldn't throw an error whenever it is trying to access these things. Okay, so that's fine. So next we will get into I mean, as I said, matrices, right? So we have matrices. So if you could see here, so what we have, so np.array 1 2 3 4 5, it's one list, and 6 7 8 9 10, this is one list. So basically this is having two rows, okay, one row and two rows, and how many columns? Five columns. So basically 2 into 5, right? 2 into 5 matrix. This is 2 into 5 matrix, right? So what I'm doing, just I'll just print, okay? So you can see how it is created. So 1 2 3 4 5 6 7 8. So this is one row, and this is other row, and this is columns, right? Okay, perfect. So second element, so I wanted to get this element, okay, 9. So I wanted to get 9. So how you'll be indexing this array? So I wanted to get 9. So how you'll be indexing the array? So I'll just use array. Okay. Previous thing, if you talk about this previous thing, let's make it as array 1. Okay, array 1, and array 1. Okay, now it is fine, and this is also fine. I'll just make it. Okay, so array 1. Okay, which is like 1 2 3 4 5. Let me print it so that you will not get confused. Okay, I wanted to access this 3 number. Okay, how you'll be accessing? You can write like this: array of 3 means 2, right? So you can get to 3. So 0 1 2 3 4, same like lists. So 2 means 3. 0 1 2 3 is the answer, right? So and then, so in the same way, for two-dimensional array, so this is two-dimensional array having 2 rows and 5 columns. So how you will be doing this? So I wanted to get 9. Okay, how I can get 9? So you will be writing like this. So first, this is first row, 0. This is second row, 1. Okay. First, I'll try to get 1. You can see I just printed 1, which means 6, 7, 8, 9, 10. Right. Now I'll be getting 9. How I'll be getting 9? I'll just write comma, not slicing. Just remember, it's not slicing. Slicing means column. Okay. This, if you could see I comma j. Generally, in case of matrices, you write I comma j, right? I comma j. So in the same way, first one is represents rows and the second one represents comma. So now I'll just try to get 9, which means 0, 1, 2, 3. I'll just make it 3. You can see 9. So 0, 0, 1, 2, 3, which is 9, right? So 1 comma 3, which is 9. So likewise, you can access the elements. So if you could see second element on the first row, so you can see second element. This is the second element, and which is the first row. Okay, first row. This is the first row, and this is second. So if you could see indexing related stuff, this is 0. That's why it is 0. And first row is 0, 1. Second element, which is 2. Answer should be 2. Okay. Answer we got it 2. So likewise, as I said, we have gone through this slicing. So any doubts here? I mean, not slicing, it's indexing. Accessing the element using the row and columns. Okay. And in the same way, we have this one. So this is three-dimensional array. So you can see three-dimensional array. There are 3 level of indexing kind of thing. So that's why it's three-dimensional array. If you could see using brackets, you have to make sure that okay, this is fine, and this is 1. Okay, this is 1, and this is other one. So we have this level. Okay. So this is 0, which is printing this, and if you go to 1, so this is 0 again. This is 1. Now we'll consider this, and again 2, 0, 1, 2, which is 6. Okay. So once you practice, you'll be able to understand this better. So just practice this. So just take this notebook and like export in your Jupyter notebook and try to practice. Like just you assume that okay, I need to get 11. Okay. Just try to first print 0. Okay, well, this one is 0. That means again this one is. It's completely based on the brackets. Okay, it's completely based on the brackets. Okay, so next we'll have, yeah, that's it. So if you're giving 1, 1, 1, so just take this 1 means, so this is 0 and this is 1, and again 1 means this one, and again 1 means this 11. So that is what it is bringing the output. Okay, so there are a lot of things, but I don't want to stress much on NumPy because it's not too much useful. I mean, basically, you'll be dealing with an actual data, right? So it's not too much useful where since it deals with a numerical Python. So you can, if you want, you can just simply go through a few things like from this exercise. But yeah, it's not too important. So just quickly go through this if you have some time. But let's just knowing the concept, what is NumPy and all, that is fine, and how what you'll be doing with the NumPy is also fine. So how to access in the elements you have done. So yeah, that's it. So next NumPy, in NumPy we have few other things like what is shape, reshape, and all. So the shape is simple thing. So you can just do yourself self explanation kind of thing. So 2 comma 4, that means 2 rows and 4 columns. So that's what shape is. Okay. We have 2 rows, 1 row, and this is 1 row, 2, 4 columns, 1, 2, 3, 4, 4 columns we have. So likewise it would be there. So you can reshape is also some kind of that that only converting some shape to other shape. So basically if you're writing reshape 4 comma 3, that means 4 rows will be created and 3 columns will be created based on the above array. And then so this all things joins, all the things are self you can learn. So you can see np.array 123 and np.array. So these two arrays we have created, and we just use a concatenation which will combine the two arrays. That's it. So if you could see 1, 2, 3 and 4, 5, 6, we can see all are concatenated. All the data is concatenated. Okay, this is one access equals to 1 means this is one different kind of concatenation. So the 1, 2, 5, 6, this is one way, 1, 2, 5, 6, and 3, 4, 7, 8. So by default access equals to 0. So it will be simple concatenation by default if you write it like this. So this and this will be concatenated, this and this will be concatenated. So like this, you can see and you can see the output as well. Okay, so yeah, that's all for NumPy, and we'll go through pandas, which is important. Okay, before working on the pandas, you have to install the pandas. So using pip install pandas, you can click, and if you could see my output, I have installed previously, so that same output is available right now. So yeah, and pandas, whenever you are working on pandas, you have to import those things. Like basically import pandas as PD. I mean, whatever you want. Just return PD, but if you want it to be anything else, that is fine. So you can generally people usually insert like import using PD. So you can also do the same. So yeah, what are pandas? So let's get into some kind of definitions and all. Okay, pandas is a Python library. Pandas is used to analyze data, and pandas for analyzing, cleaning, and exploring the manipulating data. So basically, this pandas is used for exploratory data analysis. Okay, exploratory data analysis in means like EDA. Okay, EDA generally like you already have a data, you're just analyzing it. Okay, based on the queries you're analyzing. Let's suppose you have a data set of lens card. Okay, let's suppose lens card data set, which is a best eyewear selling company in India. So basically, you have some data set of related to stores and all. Uh, you have some shortage related data set, and you have some customer feedback related data set. So you will try to find like insights using pandas. You will read those files and try to find which I mean, which kind of eye specs or specs have demand in this particular store. Okay, some people comes and I mean comes and check for some eyewear and ask, and then if they can't find it, they'll just write a feedback and go, right. So this kind of data we can feed into this pandas data frames and try to get these insights, like how many people uh, came to the store and went back giving a feedback that they need this kind of specs. Okay, so based on that you will be doing some exploratory data analysis, like exploring the data and analyzing the data. Okay, you might not find new insights, I mean like predictions and all, but okay, but you will find how based on the actual data you'll be finding and making decisions. So let's suppose in the data you got that okay, this particular Hyderabad's a particular place Lenskart office is, I mean, Lenskart store is shortage of this kind of spades, and most of 30% of the customers came to the store and went back because this particular spades are not available. Now, what you will be doing? Now, your distributor or somebody will be visiting the store or sending sending more number of specs of that kind, so that again, once the customer comes to your store, so they'll be able to get that item, so that they'll be improving the business, right. So that's how EDA processes, exploratory data analysis. They will just get the data sets and then try to do some aggregations, do some analysis, and they'll send it to business. So that's how pandas is used. So in the same way, yeah, we'll be doing all these things as well. Okay, so pandas used for that. So let's get into the pandas hands-on right away. So I'm just going through this. Okay, so in pandas we have a series. Okay, so series is nothing but one-dimensional labeled array. Okay, capable of holding any data type, and it can be created from a list, numpy array, or dictionary. Okay, so let me try to create some, okay. Yeah, I was in an assumption that since it's a numpy, so maybe it might hold numpy or not. I just thought of this. So, but it's holding, yeah. Okay, it's changing all the data types since it is holding. It's changing all the data types to same data type. Okay, so what we can do? So we have this one. Okay, we have a series, created a series 1 2 3 5 7 9 high. So these are the elements, and then we are just creating a series using PDDAS series of data. So here you can give anything, whatever you want. You can give tuple. You can. This is tuple actually. So since it is that kind of bracket, it's a tuple. If you wanted to give that element into series, you can have square brackets, which is fine. So yeah, you can also create it from tuple, list, numpy array, or dictionary. So whatever you want, you can wish based on that. You can create based on that. So here, if you could say, we have created using tuple. So I'll just edit this and say tuple. Okay, so you can pd dot series of data and then series from tuple. Okay, series from tuple is series name, and you can see we just passed 13579 high. 13579 high, which is fine. But you might not be knowing why this 0, 1, 2, 3, 4, 5 is available, right? You might be, wondering that why we have 0 to 5, right? So since this is the data, okay, this is the data, but this is just label. So label means labeling the things like indexing kind of thing. Okay, so basically we call this as label. Although it is also index kind of thing. So generally we call it as label. And yeah, that's it. So this is a single one-dimensional, labeled array capable of holding any data type. So it can't have multiple things. So if you could see again, so we have numpy and we have created a nd array, numpy array, and we are creating this array. Just we have numpy array, right, that we are creating. Through that we are creating a series. So in the same way, you can create it using dictionary. But when you are using dictionary, the key will be the label. Okay, so when you are creating a dictionary, so generally the key will be the label. So A, B, C, D, E. So you can see dictionary A, B, C, D, E, and the data is just beside it. So this data is a value, and that value is the data of the dictionary, series. Okay, so this is fine, and again, so you can create an index. So index and labels are same. This we can call it as index or else label, which is fine, ABC. So you can see data equals to A. So we have gave data as 172. Okay, we have just created a list and added elements 172. And what we have done, index equals to XYZ. So now X means 1, Y means 7, Z means 2. So likewise, it would be there, right? So I'm printing this. So you can say YZ, XYZ, and 172. Okay, so this is how you give a custom index. Okay, custom index. This is auto generate. This is from a dictionary. This is auto generated index, like zero to starting from 0 to the end, or how much data you have. That's how. But this, you can say, this is from dictionary, and this is from custom index. Whatever you wanted to have, you can have it right away like this. So yeah, import pandas as PD. So again, we have done calories. This is the dictionary, and this is calories. So if you could say day 1, day 2, day 3 is there, 3 things are there. And then, but if you could say index, we have day 1 and day 3. So now this value gets filtered and day 2 will be ignored. So that's how you deal with dictionary, pandas data frame, series, using dictionaries and using indexes as well. Based on your index, it will be showing the data. Okay, so here we skipped day 2, which is day 1 and day 3 is there. You can say that one day 1, day 3. And then now next, do you have any doubts still here? Okay, so I hope you don't have any doubts. Okay, so we have pandas data frame. So pandas data frame is a 2-dimensional label data frame, data structure with columns that can be of different types. It is similar to spreadsheet or a SQL table. So basically we have gone through series, so which is 1-dimensional array, but if you could see data frame, which is a 2-dimensional array, which means it's simple SQL table kind of thinking, syntax, simple table you can think of. And why is, maybe a table you will be having a database layer and all, particular database. When I talk about this, pandas data frame and all, it doesn't have any data. You have to just database. You don't have any database for this, right? So you just have to store it in the memory of a Python. So that is only the difference between the table and pandas. So SQL table will have database layer, but in pandas will be having only the things stored in the RAM. So and once you close a notebook or once you close a Python environment, you will lose all those things. Okay, so it's same like SQL table. You'll be having rows and columns. Pandas data frame has rows and columns, and so you can see we have data. Okay, we have created some data. So data means it's like just we create a variable called data. You can create whatever you want. You can create anything like menu, whatever you want. You can create students. Students equals to something. Okay, so it has a name. So name of key is a name and age is Bob and Charlie and none. So age is also there, the 25, 30, 35, 40, and city years and the other cities as well. So this is the data, and I'm passing this data to pd.data frame of data. So based on that, you will be able to create a dictionary simple way. The pd.data frame means it just creates the dictionary. That's it. So we have passed the data, so which is fine, and data from dictionary and data from list, which is printing these things. Okay, so display is nothing but it's like print, but if I add print, so it won't be in a proper way. This way. So if I write display, it will be showing in a completely good UI. So I that's why I prefer write display. So df from list of text. Okay, so this we have not created. I'm just removing this. Okay, so next this is dictionaries and then list, right? So creating from a data frame of a dictionary of lists. Okay, if you could see creating a data frame from list of dictionaries. So outside one is list and inside one is dictionaries. So you can see each record holds each value. So that each record holds each row, each dictionary holds each row's value. You can say this is a JSON file. So basically JSON kind of file, right? So this particular selected area will have one, will hold data for one particular user, and the other one also same. So this is how the data is designed. And now pd.data frame data of list, so which is the above one. When the data, like you can see the names and all, right? So just above data frame, and then data frame from list of dictionaries, and data frame will data frame from list of dictionaries we have created, and this is what the output is. Alice, Bob, age, Charlie, and all. So age is this, and this, and whether if we doesn't create some other column for other data, so it would be automatically NaN. So this is what a semi-structured kind of data as well. One row can have two columns, one row can have only one column, so likewise. Okay. And indexing, so index basically by in list we also have index, right? So selecting the data now. So I will quickly go through this. What is indexing? So you can see A, B, C, D, E, C, D, right? So previously, if you see auto generated are 0, 1, 2, 3. So that are auto generated. And if you could see indexing, so where it is, yeah. So this one is name, age, and city. And this is one record, and Bob 30 and San Francisco one record, and Charlie 40 and Los Angeles is one record. And so I wanted to have index for this instead of 0, 1, 2, 3, 4, 5, and I wanted to have index like A, B, C, D something. So you can create a data frame, PD or data frame data we have given, comma, index equals to custom index. Okay, and you can see the output. So A, B, C, D. And the data frame again we are creating from CSV file, so that we will be learning later on. But however, it's simple. pd.read CSV, customers.csv in index call equals to false. I mean, this index call why we got it because in the customers.csv file we might have index column. Okay, so index column we might have index column. So if you don't have that index column, you can just ignore and you can just use however you want. So you can see auto generated index and then employee one index. So this is how the data is designed, and displaying basic information about the data frame. So this is the data frame. Just we have read this, right? So I'll again run it. Okay. Now this data frame.info, which will bring you a lot of information like standard deviation information, mean, max, and all. So you can see summary statistics. Okay, display data frame info. Okay, so pandas info will bring all these things. So employee ID, which is 13 not null, integer 64. So like just basic information of the like data set, like how you use describe in SQL. In the same way, you will be using info in our databases in data frame concept. Okay, so summary statistics we have describe. So describe will bring the summary statistics. Summary, this is whatever integer values are there for this data frame, right? If you could see the integer value, only integer value is employee ID. So let's see whether it have done for only employee ID. Okay, it have done for employee ID, which is like count is 13 records are there in the data frame. And what's the mean of their employee? Generally, employee is like finding a mean of employee is not it's irrelevant. But just to understand the concept, you can check employee is 13 and 30,000. So like it means that okay, where it is 13. Sorry, I mistook something. Okay, so this is summary statistics. So just it will do an employee, but which is logicless. Okay. So if it is a salary kind of thing, me and standard deviation, these all things would be logic. But since we just have only integer column as employee ID on our data frame, we are just using describe. And then selecting specific columns. So in order to select some columns in SQL, we'll be writing select employee ID from employees table, right? But in data frame concept, we'll be writing like this. df from SQL CSV. So df from CSV and open the brackets and employee in London. So this is how you can just remove this. You can simply get simple only one column. Okay, selected column which is employee ID. That's it. So this way also possible. And if you wanted multiple things to be there, you can just write it in the list. If you wanted to understand what it is, how to do the things, you can just I think this is also fine. Shift and tab should be fine, and you can just check for an example how it does and then do the things. So now we got employee ID, and if I wanted to get this comma imp name. Okay, see, I have to write this in a okay. Now imp name is there. It's there. Okay, the email is there. I'm trying to write this as well, but why it's throwing error? Let's check. Employee name not in index. Let me check this why it's not available. Okay, let's see. I mean, I'm not sure why this is not showing the employee name instead of email. So I'll just write it again. Okay, I'll check this later on. I'm not sure why this is not giving you employee name, even though we have employee name as a column. Okay, so this is how you get the data, and then other way, this is filtering the data. So df from CSV, which is the data frame, and employee ID, which is equals to 5. So which means you're filtering the employee ID. So that means you'll be getting only 5 employee ID with 5. So how you do in where class in SQL? So the same thing in here as well. Okay, so next thing. So if you could see, just instead of removing this because it's throwing error, so I'll just show you. Not defined. Selected to column not defined. Let's remove this. Okay, you can see Vikas Patel is there. So which is like employed equals to 5, which means it is filtering the data. Okay. And then indexing and selecting the data. So indexing basics. Like in pandas, indexing refers to the process of accessing a specific element in a data frame, and it involves selecting rows and columns based on the labels or positions. Okay, labels or positions. So indexing means the same thing whatever we are doing till now. So one way is using one way is just getting the data from the this one is label, and the other one is like position. So basically you can see, so here you have a data say a simple data frame, so where we have custom index like e1 e2 e3, and data we have, so name alias Bob. So this is data we are having, like where you'll be having alias who is 25 and New York, and Bob with age 30, and San Francisco, and Charlie with age 35 and Los Angeles. So we have index e1 e2 e3. So since we have three people, we have e1 e2 e3, we have index this way, and we have data like this, and the data frame this, and we are just displaying the data frame. So e1 e2 e3, so you can see this data how it is. And now selecting a single column, we already done this df of name, so which is bringing the this only name column. And then multiple columns, you have name and city. So we already done this, but here I'm not sure why it is throwing error. So but yeah, we have done this as well, right? So this is how you get the name and city. So you can see this. Only thing is that you can write custom index, so like this. And then, so using that, so you can select the rows using the label as well. So df dot loc e2. So e2 is nothing but label, right? So now you have to get Bob. So now we have to get Bob. So e2 means getting a Bob record. Okay, you can see Bob 30 and all. And other one is selecting using iloc. So basically, whenever you are selecting iloc kind of thing, so that is using position of the row. Okay, first row position is alias, so that is iloc. So lock means using a label. So iloc means that is using this. Iloc of 0 means the first record you'll be getting. And next, so you have lock, and you also have slicing. So slicing in the sense, in list we have slicing, right? So 1 colon 3, that would bring 1 2 record. So in the same way we have sliced e1 and e2, which will bring e1 e2, and the other one e3 it will not bring, I guess. Yeah, it is bringing, yes. Okay, it's not same like list then. So e1 we are writing, so which is the start, and this will be also considered. So if you could see, E1 is there, E2 is there, and E3 is also there. And again, we can select the whatever columns you want. You want name and city column, so we got it. Okay, we just ignored age column. So that is how uh, lock will also work. Slow slicing can be possible. So you can slice based on the indexes or labels. So this one you can just give the column names whatever you wish to get the columns. Okay, are you clear till here? Log, ilog, and before what we have done, we have just done giving a custom index, and then giving the custom index and accessing a single column, multiple columns, like multiple columns can be accessed using df, and in that df again you have a list, and the list of elements which are like the same name as columns, so you'll be getting the columns. Okay, are you clear till here? I'm expecting some replies from you. Are you clear? Okay. So yeah, I hope everybody is clear. So again, selecting the rows, and we have done. Okay, next conditional operator. So basically conditional sections like filtration, right? We have done this already. So basically, so what you are doing, we have df, okay? Df, we have, let's see the data first. We already looked into the data. So yeah, we have the data here. So I wanted to get whose age is 25. So how I can get this? Let's write this way, single quotes, age, and then I'll write greater than, okay, I'll just make it greater than or equals to 30, which should bring these two records, okay? So you can see E1 is false, E2 is true, and E3 is true, right? So E1 why it is false? Because we have 25 age. And now I'll just write df, open the brackets and close the brackets and look at the data. Okay, this age is giving only true false. Based on the true false, again you are doing ls, df, data frame, open and close the brackets. In that you'll be applying the function. So that's how you'll be filtering the data. Okay, you can see here. So we are just having like age greater than 30 and age df and again df. So which this brings the true false kind of syntax, this particular piece of code, and that true false passed into the same data frame, and then that data frame will be copying the data, just filtering the data and showing the data. So if you could say name equals to Alice, which also printed only Alice. Okay. If you wanted to get using this one, you have to use lock. Okay. Data frame dot lock of E1. Likewise, you have to get the data. Okay. And next we have hands-on questions. So basically create a data frame with information about students, including name, age, grade, and city. Okay. So we have to create a data frame whose column names includes name, age, grade, and city. And now we have this data frame, so you can see the data how it is. So we have a name, we have age, grade, and city are the keys, and again we have list of details. So age is 22, grade A and New York. So in the same way, Bob 25B and San Francisco. So this is the data. So you can create data in a number of ways. Like you can create the data in list, and within this list you can have each record for each dictionary, or else you can have dictionary, and within the dictionary you can have list. So it's your choice. Okay. So and then I have created a data frame using pd data frame and data. That's it. And next again we have select and display the display name column. So we already have the data and we're just displaying the name column. So student df name, that's it. Okay, select and display the rows where age is greater than 20. So df age greater than 20, and again you have created like this. So it is bringing the 20 age less than 20. And you are just trying to get name and a grade column, just simple, but it's simply simply getting the multiple columns in a data frame. Okay, and select and display a subset of data frame. So this is the data frame and which is equals to b, and means like and operator. Okay, if both the conditions are true, then only gives you the data. So this is true and this is true. So then it will bring the data. And again also we have done right start str, whatever data it brings, we have converted it as str and starts with s. So we are making starts with s. Okay, city starts with San Francisco. So this condition is this: if city starts with San Francisco, so then only it's true. And if it is true and this is true, if the grade is B, then only they will be, that particular data will be shown to us. Okay, so this is all about reading reading a data frame from dictionaries and list and all, and trying to modify the existing auto generated labels like 0 and all, 0 1 2 3. So you can pass your labels whatever you want. And we have also learned how to get the single column and multiple column. Okay, so and also we have gone through log and dialog as well. And also, yeah, these few things we have done, and we also gone through hands-on related stuff. And next we have missing data. Okay, so basically what is missing data? So let's suppose you have this uh, n value, so not a number value. Okay, so not a number or none value, so these are null values. So in the same way how we have in SQL table null values, right? So we have null values, like we were using this select star from employees where phone number is null, which would bring null who, like the records whose phone number is null, right? So in the same way, since data frame is also same like SQL, so we will be having these things as well. So what we'll be doing, so we'll be creating a data frame, create some scenario based on the null value. So np.nan is null value. Okay, so np.nan means like not a number. N means not a number. That means it's a null value. So we have created few data who alias Bob and null value and David. So we'll just deal with this. So so we have this data frame and data. So and then df with missing. And how you will be checking whether the particular data frame has null values or not? You can use isNull function. Okay, isNull. Just remember this function, which is isNull. And now we are printing this. You can check this. Okay, I'm just segregating this using some loggers. So just try to don't consider this. First, you just go through this. Okay, both seems to be similar, so anything is fine. So I'm just removing this. Okay, so you can see I just returned is null, so which means wherever this value is, we have np.10, there it should be true. Okay, that means names with the third one should be true. You can see third one, names with the third one before David. This is the one which is true. And if you could see last one, that means grade with the last one should be true. Which is null value. So if it is null, it will be true because the condition is null. Okay, is null. So that means it should be like if it finds some null value, it will be true. Okay, that's it. And next, same thing. So same thing. It's represented in different box, and this is represented in different box because this is a display function we have used, and this is just a print function. So generally, display function what it does, it will give you more of readable format. I like display function actually. If you look at the data, you can see it's in like SQL table. Okay, so it's not simple plain text. It's a like SQL table kind of environment, if you could see. And how to deal with the null values like missing data. Okay, so let's suppose you have some data set, and in that few people have phone number, few people doesn't have phone number. Okay, let's suppose you have like 100 records, and there are around like 100 phone numbers, and rest of the 900 are null values. So if you don't have this, maybe your requirement or your business requirement doesn't have they don't require this phone number column at all, right? So what you will be doing, you'll be dropping that column, right? So since there's no requirement, so why to store the data in our database or in our data frames or in our storage space? So if you don't want that particular column, just leave the column, right? And moreover, that particular column is also not having data. Few records have data, few records doesn't have data. So there is no use of holding the data in our database systems, right? So at that moment, so we have to use, we have to deal with some kind of missing data related concepts. Okay. So now we have drop NA. Okay. So drop NA and fill NA kind of concept. So if you could look at this DF with missing data, exact data, so you can see we have a list. The first record, nothing is null. Like a list 22, age 22, and grade A, which is fine completely. And Bob with 25 age and B, which is fine again. And you can see the name third column, name is nan value. So nan means null value. Okay, just it's a null value. And the age is 37 and grade is C. Okay, so now you can see one column is one value for the column, like one column for the one column in that particular row has null value, and the third one also has null value, which is grade. Okay, so now what we'll be doing, we'll be just dropping these things. So let's try to create one more scenario, making this age also null. Okay, making this age also null. 35 np dot nan. Okay, so now I'll just update this one. So you can see David, Nan, and Nan, right? So now, which means this last line, we just have only name. That's it. No use of anything. I mean, no use of other data set, because we have null value. Only one thing we have it is name. That is David, right? So what I will be doing, I'll be dropping that particular record itself, because I don't have much information about that particular record except the name. Okay, so in real time use cases, you might be having this kind of requirement. Okay, like you'll be having a lot of data sets. Okay, like maybe 1 lakh or 1 million data set, and you want at least 5 columns to be a not null value. Okay, but in our case here, we have 3 columns, which is name, age, and grade, and in that 3 columns itself, only we have name value. The other 2 values are null values. So what is the use of that record at all? No, right? Only with name, it is not enough to process or do some analysis. So what we will be doing, we will be trying to drop, drop that particular column using this drop any syntax. So df with missing dot drop any threshold equals to 2. Threshold equals to 2 means at least 2 columns should have some value. Okay, let's look into this. This column has values. It's more than 2. Okay, because we have written 2, but if you could say we have 3 not null values for this column. For this column also, it's fine. And if you could see this column, we have 1 null value, but if you could see 1, 2. So this also meets a condition. Threshold equals to 2 condition. So this also meets a condition, and this will be this won't be dropped. Okay, and if you could see this David, and if you look at for other few, those are null. That means this not null columns are only 1. But if you could see threshold, which is 2, which means threshold equals to 2 means, so basically drop in is expecting if not null values are more than or equals to 2, then it shouldn't drop the value, drop that record. But in case of this, David gets dropped because threshold equals to 2, which means threshold drop in is expecting that particular record should have 2 not null columns, but here we have only 1 not null column, so it will be dropping the record. So next I'll just enter. You can see Alice, Bob, and Nan. Only one is there. But if you could see, this David is not available because this record doesn't qualify for undropping the record. Basically, not dropping it doesn't qualify for missing value. So basically, threshold equals 2, which means threshold is expecting 2 not null values, but we don't have 2 not null. We have only 1 not null value. So that's why David got dropped. Okay. So again, we have fill NA. Fill NA means filling the values, filling the null values. So I'll just enter this. You can easily find what is the difference. Okay, so if you could see, this is the original DF, right? Original DF. Here we have none, here we have none, here we have none. So since we have written unknown here, so fill NA unknown. So which means whatever you're writing, so that is filled, that null values is filled with unknown value, right? So basically in the same way, in the same way, let's suppose you have a data set which is having a phone number column, and in the phone number column, few have phone numbers, some have in nan values. So what you will be writing? You will be writing not available instead of nan values. You can write not and available or applicable something. Okay, so which is fine, right? So at least you have some data, that you have some data that you might not have exact phone number, but you have some data that okay, this particular phone number is not available. So likewise, so you can create you'll be having a data frame, you'll be having a phone number column. So maybe let's suppose you have 1,000 records. In that 1,000 records, you have your 1,000 records might have 900 records might have phone number, exact real phone number. The other 10 records might, other 100 records might have, null value, and you want to fill that other records null value with unknown value, and some kind of not available or not applicable kind of, constant value. So what you will be writing, you will be writing df.fillNA, and you will be writing not available. So in the same way, how we have done unknown. Okay, so this is how you'll be dealing with null values using